H2 computing at TJC, in 2021, this is the first year that we are actually supposed to offer computing to all prospective students. So what H2 is computing is all about. Okay, let me bring you through this. Okay, H2 computing, what you will generally learn will be classified into four main categories. First, the first component being your algorithms and data structures. The second component being programming itself. The third component, data and information management. And the fourth component, computer networking. Now, it is not possible for me to go through what every component will be covered, okay, to you today, but let me just focus on one of the components, algorithms and data structures, which is what the sample lesson will be about. Okay, in algorithms and data structure, what you will mainly learn at 8 levels will be your fundamental algorithms, okay, that teaches you how to search and sort in a systematic way. Okay, you will also learn how to write pseudocodes and draw flow charts of these algorithms that are used for searching and sorting. And lastly, okay, write them in programs to organize data. Now let us look at a very simple example. Now, if you have a pen and paper beside you, or you might want to grab a piece of paper and a pen, you might want to try sorting the following set of numbers in ascending order. 64, 34, 25, 12, 22, 11, and 90. Now, let me just give you about 2 minutes. Maybe you can try sorting these numbers. It shouldn't be difficult. And after that, we'll look at how we can actually sort them systematically, okay, using a very specific method called the bubble sort. Okay, for students who have just entered, you might want to take out a piece of paper and a pen to try sorting the following set of numbers that you see on the screen: 64, 34, 25, 12, 22, 11, and 90. Okay, I'll continue shortly, okay, to explain the algorithm of bubble sorting to see how these numbers can be sorted in a systematic manner. Okay, about 2 minutes have passed. I'm quite sure the sorting was pretty simple. Okay, but let me just use this simple set of numbers to illustrate a more complex algorithm that is used to sort a larger set of numbers. Okay, the bubble sort algorithm. So what happens over here is I have the numbers 64, 34, 25, 12, 22, 11, and 90 all jumbled up. So I'm going to start systematically from the first number, 64. I'm going to compare it with the next number, 64 and 34. Since 64 is larger than 34, I'll rearrange 64 and 34 to get 34 and 64. Of course, the rest of the numbers, 25, 12, 22, 11, and 90 are still jumbled up. Next, I will actually compare the numbers 64 and 25. In this case, 25 is smaller than 64, so I'll be rearranging them again to get 34, 25, and 64. And notice that I'm going to likewise follow the pattern and compare the next two numbers, 64 and 12. to get 34, 25, 12, and 64. Okay, followed by the next two numbers, 64 and 22. That gives me 34, 25, 12, 22, and 64. And of course, if I finish sorting the entire sequence, I will end up with the final value, final arrangement to be 34, 25, 12, 22, 11, 64, and 90. The sorting of 64 and 90 is not necessary since 64 is already smaller than 90. And in this entire process, notice the only number that I'm moving is just 64. I'm just moving 64. I'm not touching any of the numbers. Okay, only 64 moves through the entire column. So this is one cycle of the bubble sort algorithm. And from here, I'll move to the second cycle with 34 being in front. So now I'll compare 34 and 25 again. In this case, 25 is smaller than 34. And comparing 34 and 12, I get 25, 12, 34. Okay, this seems pretty tedious, right? So if you complete the arrangement, you end up with 25, 12, 22, 11, 34, 64, and 90, where the movement of 34 stops over here after comparison with 64. There's no need for me to sort the rest of the numbers 64 and 90 because they're already sorted. So your 34 will only travel through the entire sequence until it reaches before 64. Now that's the second cycle. I'll move on to the third cycle, focusing on the numbers 25, 12, 22, and 11 only. 34, 64, and 90 has already been sorted. So just sorting 25, 12. Yeah, 12, 25, 22, 11. And if you do the sort correctly, you will end up with 12, 22, 11, 25. And the three numbers at the back will just follow through to be 34, 64, and 90. Okay, this is a very simple list of numbers. So if you continue the algorithm completely, you eventually reach 11, 12, 22, 25, 34, 64, and 90. And notice how many slides I have transited. Okay, there's definitely a few more cycles to it. Okay, notice my movement of slides until I reach the end of the sequence. So with this tedious algorithm, okay, it will be very difficult for you to try sorting the next set of numbers. Why not give yourself a minute or two to try using what I have demonstrated to sort the following set of numbers, starting from 907, okay, sort it into order. Okay, this will be pretty difficult. So that's when computing comes in and programming. We have systematic ideas of how we arrange numbers, but we will need, okay, to automate the process. Otherwise, you will be doing what I'm doing on the slides now. Okay, trying to arrange the numbers one by one. So let me share another screen. Okay, what you are looking now is a website called codecollab.io. Okay, this is one of the platforms that we will use very frequently if you actually join H2 computing. Okay, let me zoom in first. And I hope you notice that during the arrangement which I have made, there was a main focus that I was comparing. I was comparing two numbers. Okay, the number that I'm moving through and the number that's next to it. So let's just consider a list where I call this list an array. Let me zoom in first. Okay, pardon me for a technical error. Okay, let's call the list an array. ARRAY is an array, which is a list of numbers, but for short, I'll just call it ARR. So what I'm actually arranging is basically comparing two elements. Let's call this the element in the jth position. Okay, the element in the jth position, and I'm comparing it with the element in the ith position, j plus 1th position. Okay, so position j and position j plus 1. And when comparing these two elements, okay, this is what you will see. Over here, two lines. The element in the jth position of the array, which is the list, and the element in the j plus 1th element, okay, j plus 1th position. I'm comparing these two elements. Okay, and if the element in the j position is greater than the element in j plus 1 position, I will rearrange them. So I have this thing called the if condition. Some of you may know what the if condition is if you have already done some coding before. So if the two, the first value, the one in the jth position is larger than the one in the j plus 1 position, I will rearrange them in this manner. Okay, the element in the jth position and the element in the j plus 1th position will be swapped to become the element in the j plus 1 position coming first, and then the element in the jth position. This will be the rearrangement that we see. That's the first thing that we will notice about this algorithm. And then, while trying to understand the algorithm, you'll notice that the second focus that I have made was that, okay, I only concentrate on the numbers that I have yet to arrange. So numbers that have been arranged are not touched. So I can add in another for loop, okay, what we call the for loop range, for j in range 0 and n. Okay, let's just use a variable n first, and we'll see what this n means later. What this element I means later. So basically, what this n and I means is that the length of the list is defined as n. The length of the list is defined as n. So len is actually a command that helps you calculate the length or the number of elements in the list. So this is n. Okay. And I'll define a value called I in range n. So what is this I in range n about? This I is basically used to transit the number that I'm considering across the entire list. And after this number is arranged, I will stop considering it. That's why I have what you see, n minus I minus 1. Okay. Okay, let me space it out for easy reference. And then I'll define this as a function. Okay, this function is called the bubble sort function. So this bubble sort function will take in the list of length n and move an element across the list for a cycle. And whenever it arranges the values, it stops considering the value that has been arranged. So this is what I have. And I can use this function to sort any numbers. Okay, for example, now I want to define a new list. This list was what you see in the PowerPoint slide just now, the list of 3-digit numbers. You can see my list of 3-digit numbers: 907, 112, 534, 435, all the way to 235, the entire list of numbers. So this is the list that I'm going to arrange. So with this bubble sort function that I've coded, things become a lot easier, because just with these few lines of code, these 6 lines of code, I can actually arrange a set of numbers. So I'm going to run the bubble sort function. So I'm going to sort the array. And then I'm going to print out the new array. Now notice that my right panel, the one that I'm expanding now and trying to make the code disappear, the right panel, what you will see is when I try to run this code, did I type anything wrongly? And I try to run this code. It will arrange the numbers. Let me check for any error. Okay. Okay, there you are. Sorry for the formatting. Okay, I extend an extra tab. So you can see the numbers being sorted 112 all the way to 933 in ascending order. Okay, so that was a demonstration of how coding can actually automate certain processes to make things faster. And with coding, we no longer need to do a manual sorting of the array of numbers, which we have seen over here.